when things were very extreme, very different. And in that environment, these things were allowed. And these forces were basically the same, right? But yeah, I don't know about parallel universes. That is more of a sci-fi thing at this point than it is a science thing, because we don't have evidence of such a thing, okay? Okay, so the original string theory that emerged from Veneziano's work in the late 1960s. So string theory is from the 1960s. It's a candidate for a grand unified theory. I will just warn you, it's a very mathematical, very geometry-y theory. I am not an expert of it, but I do study, I will read about it and study it. But it's a very mathematical, very geometry-based theory. And of course, it's based on general theory of relativity. So you can be assured that string theory will respect general theory of relativity, which is a good thing, because general theory of relativity is an extremely successful theory. To a large extent, it has been proven right. Its predictions have come true. It stands the test of time. It's not perfect. It doesn't explain everything, but it is extremely successful to a large extent. And string theorists always start with GR. Basically, general theory of relativity already stepped out of the usual way of doing things by going for space-time and having four-dimensional mathematics and geometry, where time is one of the dimensions and spatial dimensions, there are three of them, like the usual, so four space-time. And all the math is done with this four-dimensional space-time thingamajig. As in, usually we do math with the three spatial dimensions, and we don't regard time as one of the sort of same things. But in general theory of relativity, time is one of the dimensions. It's space-time together. It's not space you're here and time you're here. It's like four space-time. So in the four space-time geometries, general theory of relativity is established, all the equations, all of that is done. String theory takes all of that and actually adds more dimensions, extra dimensions, and does the math with even more dimensions and finds a way to explain things with that. So it's a very mathematical, very geometry-based theory, once again. And it started really in the 1960s. Now, you'll remember that Einstein worked a lot on unifying the forces, on trying to come up with Einstein worked very hard on trying to get a grand unification theory and trying to have a theory that would subsume general theory of relativity, electromagnetism, quantum mechanics, all of it, right? And explain all of it. But he didn't succeed. He died trying. After his time, string theory started to be a thing in the 1960s, and that's sort of the timeline of that theory. So just wanted to let you know from where in the history we get string theory. So we just talked about supersymmetry. Now we'll talk about supersymmetry in string theory. The original string theory that emerged from Veneziano's work in the late 1960s incorporated all of the symmetries discussed at the beginning of this chapter, but it did not incorporate supersymmetry, which had not yet been discovered. So supersymmetry as a theory was not yet discovered at that point. This first, so because again, string theory too has evolved. It's not like the string theory of today is not the string theory of the 1960s, right? It's been, oh gosh, it's been ages since the 1960s, right? So I guess it's been 60 years. So 60 plus years. So string theory is a boomer.